Okay, guys, greetings. This is a presentation for 13.2 arithmetic sequences. Now, arithmetic sequences is any sequence where the same number is added or subtracted. Now, we always like to think of it as addition. Excuse me, because if I add a negative number, it's going down. I apologize. Something is my eye. Okay, so let's look at these. 2, 3, 4, 5. Pick out the pattern. 6, 7, 8. Right. The difference here is a positive 1 because from term to term to term, it's going up 1. Consider the sign on your difference. 5, 10, 15, 20, 25, 30, 35, and so forth, right? What's happening? It's going up 5. So that's my common difference. Look at this one, 16, 13, 10. This is going down. 7, it's going down by 3. So the next one will be 4, and then 1, and then -2. Since it's going down, my difference is a negative number. It's, in this case, a -3. Now, look at this one. A plus D, A plus 2D, A plus 3D. I bet you can go this. A plus 4D, A plus 5D, A plus 6D. This is actually what every arithmetic sequence looks like. The pattern is there is an A plus some D's, okay? Now, really the pattern is you take the first number plus the difference times the number of terms minus 1. Because look at this. On the first term, there's 0 D's. On the second term, there's 1 D. On the third term, there's 2 D's. So see how this is always 1 less. So A, this is just the first term. D, that's the common difference. And what we have over here, let me catch up with myself, common difference. What we have over here is the generic formula for an arithmetic sequence. This is one to memorize. You got to know it, okay? No ands about it. Okay, let's go with this. Let's go with some questions on this. Now, here's the sequence. It's arithmetic. Okay, now first, I want you to be able to know, how do I know this is arithmetic? Well, it looks like, it doesn't look like our a sub n equals the first term plus the difference times n minus 1. It doesn't look like that. So how do I know that's arithmetic? Well, let's look at this. If I want to find the first term, that means I put in a 1. 3 times 1 is 3. 3 plus 5 is 8. 3 times 1 plus 5. Okay, the second term is 3 times 2 plus 8. 3 times 2 is 6. 6 plus 8 is, why am I doing 8? I was confusing myself. 3 times 2 plus 5, right? Yeah. Okay, because it's plus 5. Okay, 3 plus 6 plus 5 is 11. Okay, a sub 3 equals 3 times 3, which is 9 plus 5. It gives me 14. Check it out. 8, 11, 14. Oh, the next one will be 17. It's adding 3 each time. That's one reason I know it's arithmetic. Think about this. If I was to make the equation like this, a sub n equals the first term, which is 8, plus the difference, which is 3, times n minus 1. I could actually go 8 plus 3n minus 3 after I distribute that 3 through there, right? And then I could combine this 8 with the minus 3, and I could get 5 plus 3n, which is exactly what I've got there. These are often written so they look more like a line mx plus b. But the big key is you've got a number times n and then some other numbers being added to it, okay? 8, 11, 14, 17. The next one's going to be 20, okay? There's your common difference, okay? This is not the first term. The first term you always find out by putting a 1 in there, okay? Okay, so there's a lot of ideas there. Oh, find the 40th term. Well, the 40th term is just going to be found by putting 40 in, and I'll put it into the original equation. 3 times 40 plus 5. 3 times 40 is 120, plus 5 is 125. Of course, if you didn't want to use the formula, you could just go 8, 11, 14, 17, 20, 23, 26, 29, 32, 35. I lost count. Start over. See what I mean? You go 40 terms out and do it that way. That's one way, not the most time-efficient way. Okay, let's look at something else. Find the nth term. The nth term. What the heck's the nth term? Well, the nth term is just a sub n. Okay. Well, the nth term, first term is 7, so it's going to be 7 plus common difference of 5. Well, 5 times, n minus 1. There's the nth term. The nth term just means find an equation. Now, find the 51st term of the sequence, a sub 51. Well, that's just 7 plus 5 times 51 minus 1, which is just 7 plus 5 times 50, which is 257. Yay, I'm happy. Cool. Oh, 3 eyes. Sorry. The mutant guy. Whew. Alien. Okay, there it is. So to find a sequence, to find an arithmetic sequence, I can use that formula, that generic formula that we had up earlier, and to find any value, I can plug the number of the term into the equation. Let's look at some other things. Find the 98th term of this sequence. Well, there's the first term is 2. What's the common difference? 2 to 6, 6 to 10. Well, it's going up 4, so the difference is 4. So my equation is a sub n equals, the first term is 2 plus the 4 times n minus 1. Now, I could simplify that, but I don't need to. Because to find the 98th term, I just have to put 98 in there. 2 plus 4 times 98 minus 1. I don't want to do that in my head, so I'm going to use my calculator for a second. I don't like that calculator. I want a different calculator. Somebody stole my good calculator. Give me a second. Oh, there it is. Sorry, it was right in front of me. That's why I didn't see it. Okay. Okay, there it is. 2 plus 4 times 98 minus 1, that's 97. 390. So the 98th term is 390. Ooh. Okay, cool. Moving on. Now, let's look at this way. One day, Carl Frederick Gauss, 10 years old, student in the class, had a strict teacher. Teacher got ticked off at him and said, go in the corner and add 101. And numbers 1 to 100. Don't come out till you're done. That's the way the story goes where I learned it. He immediately had the answer. Showed up as teacher, right? We all want to do that. Don't do it to me or I'll get ticked off. How do you do it? Well, check this out. 1 plus 2 plus 3 plus 4 plus, let's go 97 plus 98. You added all these things together really quick in your head. Have you done it yet? He did. Check this out. If I add 1 plus 100, I get 101. If I add 2 plus 99, I get 101. If I add 3 plus 98, I get 101. 4 plus 97, I get 101. All of these pairs, as I go from out to in, the bottom pair is going up, the bottom number is going up by 1, the top one's going down by 1. So in effect, they're adding to the same pair. Well, not in effect, they are adding to the same sum. How many pairs are there? Well, numbers 1 to 100, there are 50 pairs. So 50 pairs times 101, 5 times 101 is 505. Add the 0 because it's 50, and I get 5,050. This gives us our sum formula. If we take the first term plus the last term and multiply it by the numbers we're adding, the number of digits we're adding together divided by 2, that gives us the number of pairs. That gives us the sum of n terms in an arithmetic sequence. There's a formula to, again, memorize. Tattoo it on your brain, not your arm, because it would be stupid. Okay, moving on. Find the sum of the first n terms, and I'm going to use that summation formula. S sub n equals n over 2 times a sub 1 plus a sub n. So I look here, and I go n of terms, n terms. I don't know what n terms are, so I guess I have to go n over 2 times the first term. Well, the first term is just 3 times 1 plus 5. Well, that's 8. So 8 plus, so this is the sum, equals the number of terms divided by 2 times 8 plus the nth term. Well, the nth term is just this. Oh, I guess I can just put in that. 3n plus 5. Oh, check this out. N over 2 times 8 plus 5 is 13 plus 3n. And what I found is if I put the first term and the formula in there, I've now come up with an equation that I can find the sum of any terms on this sequence, starting at 8 and going to however I want to do. Cool. Now, if you're doing a lot of them at once, that might be a good approach, but let's try just the one-time thing. Find the sum of the first 30 terms of this. Cool. So it's going to be the sum of 30 terms is equal to 30 over 2 times the first term, which is 5, plus the last term, which is not 11. So I got to find the last term. So let's do this. 14, 5, 8, 11, 14, 17, 20, 20. I've lost track. 1, 2, 3, 4, 5, 6, 7. It'll take us a while to get to 30, so go grab a soda or something. No, I'm just kidding. That's one way to do it. That's not the most time effective, and if you make one little mistake, it's done. Okay? Now, but another way is look at this sequence, 5, 8, 11. This is the sequence, the first term plus the difference times n minus 1. Well, this is just 5. Oh, we've recognized this, right? 3 times n minus 1, 5 minus 3, which is just 3, and 5 minus 3 is plus 2, right? So if I put a 1 in there, I get, so this is the equation for that sequence. If I find the equation for that sequence, I can find the 30th term. The 30th term is just 3 times 30 plus 2, which is 62. Now I have this. So I don't have to be given everything to find the sum. I can use the sequence itself to find the last term and go there. Now, let me give you a danger. A nice danger of something like this is say, well, I forgot the formula, so I'm just going to go 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23 plus 26 plus 29 plus 30, all the way up to plus 62, making sure I count the number of terms and type in my calculator. If you do that on a test, you will not get credit, okay? Because you're showing that, hey, you can create the sequence and you can type it in a calculator rather than using an algebraic approach, okay? So memorize the formula. 5 plus 62 is 67 times 15. 30 divided by 2 is 15. So I did some of that in my head, and I end up with 1005. Cool. Moving on. Find the sum of this. 2 minus 1 minus 4. So I look at this. 2 minus 1, it's going down by 3. Minus 4, that's going down by 3. Okay. So this is arithmetic where the difference is negative 3. Okay, so the sum of an arithmetic sequence is equal to the number of terms, which I don't know. But I do know the first term is 2, and I do know the last term is a negative 73, but I need to find the number of terms. So again, I could hold up my fingers and I could go 2, negative 1, negative 4, negative 7, negative 10, negative 13, negative 16, until I held up all 40 fingers, except I don't have 40 fingers, and I don't even know if there's 40 terms, but I run out of fingers. But probably a nicer way is, think about this. Use this formula. A sub n equals the first term plus the difference times n minus 1. Think about it. A sub n, that's this negative 73, is equal to the first term, that's 2, plus the difference, plus a negative 3, plus a negative 3 is minus 3. The difference is minus 3. Sorry, minus 3 times n minus 1. I don't know n. So I can solve this. Negative 73 equals 2 minus 3n. Negative 3 times negative 1 is a positive 3. Negative 73 equals 2 plus 3 is 5 minus 3n. Okay. If I subtract 5 from each side, negative 5 I get negative 78 equals negative 3n. And if I divide by negative 3, 78 divided by 3, I know it's going to be positive, is 26. So I can go on my fingers 2, negative 1, negative 4, and count out till I count all 26 of my fingers. Or I can use this little deal and set the last term equal to this and find the number of terms. That's 26 terms. Now, hey, that's a calculator problem. 26 over 2 is 13, and 2 plus a negative 73 is negative 71. If I multiply those together, I get negative 923. So the sum of an arithmetic sequence could be a negative number if you're adding a whole bunch of negative numbers, like in this one. Cool. Let's keep going. Hey, word problems. I love word problems, don't you? Yeah, stories and problems, put them together. I love stories and problems. I like story problems. The corner section of a stadium has 30 rows of chairs. The first row has 10 seats. Okay, so 10 seats. And then each successive row has 14 seats. So the next one has 14, then 18, and then all the way up to 30 rows, right? 30 rows. How many seats are in the top row? I don't know. I could go 10, 14, 18, 22, 26, 30, 30. What am I adding? I've forgotten. So that's probably not the way I'm going to do it because I'm kind of dense that way. But I'm going to look at this and I'm going to think, I'm looking for the 30th term. Well, the 30th term is going to be the first term, which is 10. Oh, by the way, we know this is arithmetic because it's adding 4 every time. So the difference is 4 times n minus 1, and n is 30 minus 1. Hey, that's a calculator problem. 10 plus 4 times 30 minus 1. I typed that whole thing in. I didn't even do any in my head. And I get 126. So there's 126 rows in the top row. So how many rows are in the section? That's asking me to add together all 30 rows. So that's 30 over 2 times the first row plus the last row. Cool. 30 over 2 is 15, and 10 plus 126 is 136. So that's 2,040. 2,040 seats. That's a big stadium. Well, I don't know. If it's a corner, there's 2,000 in each corner. That's like 8,000. How many are going to be in the sides? Maybe triple that? So like 24,000. That's 30,000. That's a good-sized stadium. Yeah, that's a good-sized stadium. It's bigger than our stadium here at Roy High. Cool. Moving on. A company A pays $2,040 yearly with raises of $1,600 a year. Company B pays $28,000 with raises of $1,000 every year. Which company will pay more in year 10? Which company will pay more over 10 years? So if I look at company A, let's think about that. Starts with $24,000, and then every year it raises $16,000. So it's going to $1,600. So 25,600, and so forth until I get to year 10. Well, what's year 10? Well, this is an arithmetic sequence, so I can go, the 10th year is just going to be the first year, which is 24,000, plus the raise, which is 1,600, times n, which is 10 minus 1. So 24,000 plus 10, not 10, 1,600 times 10 minus 1, that's 9, gives me 38,400. Okay. Company B, and then you know what? Why I'm doing this, dealing with company A, I might as well figure out the sum. The sum of 10 years of pay is going to be 10 over 2 times the first year, 24,000, plus the last year, 38,400. And that gives me something. I'm typing in my calculator. I get $312,000. So their total package compensation for 10 years is $312,000. Okay, company B, these guys pay $28,000, but they only give $1,000 a year, so 28, 29. So year 10. The 10th year I could find by going the first year, 28,000 plus the raise, that's 1,000 times 10 minus 1, which is 9, like I was writing up. Well, 28,000, 10 minus 1 is 9,000 times 9 is 9,000, 28,000 plus 9,000 is 37,000. So these guys pay less. Those guys pay less in the 10th year. So what do they pay total? Well, it's going to be 10 over 2 times 28,000 plus the last year, 37,000. That's going to be equal to 28,000 plus 29, 37. 37,000. That gives me a total cap package of $325,000. Interesting. So company B pays less on the 10th year, but pays more on the total compensation, like $13,000 more. Which job do you want? I don't know. They both have their benefits, right? I mean, the job B pays more over the long term, but I mean, the less. So, but you'll get to a higher point in company A. I'd be interested to see if they continue that, because eventually company A will pass over company B, I would think, wouldn't they? Yeah, because they have that's like a slope, and it's a steeper slope, so it's like that. I wonder how many years it takes for company A to equal company B in their total package compensation. To do that, you'd have to set these equal to each other and solve for n, which means I would have an expression here instead of that. That'd be a more complicated question. That'd be a cool question. I like that. Okay, look at this. This is a little bit different. An arithmetic sequence has a common difference equal to 4, and the fourth term is 13. So fourth term is 13, and then difference is 4. So I'll be honest, I would go 13, 17, 21, and so forth. And that's the fourth term. So the third term is 9. Second term is 5. First term is 1. Wow. Okay. So the 12th term, I already got 6 terms there. 1, 2, 3, 4, 5, 6. I might as well go to the 12th term, or I can just do this. This is the first term plus the common difference. That's 4 times, and what n is 12. 12 to a 12. So 12 minus 1. 12 minus 1. 1 plus 4 times 12 minus 1, which is 11, gives me 45. 12th term is 45. Okay. Now, on a test, find the 12th term. If you just count it up, 1, 5, 9, 13, 17, 21, you might get credit for this. That's okay, because they just said find the 12th term. So if you just went 21, 25, 29, wait, what am I doing? Going up by 4. Yeah, 33, 37, 41, 45, and said, hey, there's the 12th term. You probably would get credit for that because it didn't instruct you not to do that. But here, if you just went in your calculator and you went 1 plus 5 plus 9 plus 13, all that, you would not get credit for part B, because this says use the appropriate formula. So show an algebraic approach. So I would need to go S sub n equals n, which is 12 over 2 times the first term, which is 1, plus the last term, which is 45. Now, once you've written down that formula, if you actually go in your calculator and go 1 plus 5, that's fine, because you can't tell the difference. but you've gone through the trouble to find the formula. Might as well type it in. 12 over 2 times 1 plus 45 gives me 276. You need to memorize the formula. Okay, period. There's no way around it. Cool. Let's look at this. Wow, look at this. Fourth term. Fourth term is 12. Eighth term is 20. Find the common difference. Well, I like to do this. 12 to 20. That's 8. So really I've gone, 20 minus 12. They're 8 apart. And look at this. 8 minus 4. That's 4 steps. 8 over 4 is 2. So guess what? That's my common difference. My difference equals 2. Now, does this look familiar? It should. That's like the slope formula. Okay? The slope formula works to find this. Now, I'm looking at this 12 to 20. It's going up, which means the difference is positive. So I always kind of double check, make sure I got the right sign. Now, use the appropriate formula to find C of 20. Whoa. Which means now I couldn't just do this. I couldn't just go, 20, 22, 24, and so forth all the way to the 20th term. I think this is 8th, 9th, 10th. I have to use an appropriate formula, which means I have to use an appropriate formula. Well, the appropriate formula is the 20th term is going to equal the first term. I don't know the first term. How about the first term? Well, 12, 10, 8, 6. So this is fourth term, third term, second term. There's my first term right there. So 6 plus the difference, which is 2, times n, which is 20 minus 1. And there I go. 6 plus 2 times 20 minus 1 is 19, and that gives me 44. So the 20th term is 44. Use an appropriate formula. Okay? You're going to see that as a phrase on tests. You need to make sure you know the formulas, because if you don't know them, you can't use them and you won't get points. Okay? Guys, that's almost it for arithmetic. I got one more thing, I think, for you, right? Yeah, one more thing, and then we're going to be good. Here, the third term is -4. The seventh term is -16. So -4, -16. That's going down. So my difference I know is going to be negative. What's it going to be? Well, I can do this. My difference is going to be -16 minus the -4. And then 7 minus 3. -16 minus the negative, that's plus. That's -12. 7 minus 3 is 4. -12 over 4 is -3. My difference is -3, and that fits because I know it's negative. Use the appropriate formulas to find the 26th term. Well, let me think. If the third term is -4, and I'm going down by -3, it goes -4, -7. This is going to go the other way. -1, 2, right? 2 minus 3 is -1. -1 minus 3 is -4. Yeah, that works. So there's my first term. So the 26th term is equal to the first term, 2, plus the common difference, so plus a -3, times n, which is 26 here, minus 1. Okay, so I'm going to go 2 plus the -3 times 26 minus 1 is 25, and I get -73, which fits with what I know because it's getting more and more negative all the time. So there's my answer there. This just kind of gives you all the variations of what you could be asked to do, where you find the sequences, you find the steps, but you could be given 2 terms, you could be given first term and a difference, the difference in the first term and the last. There's lots of different combinations of things you could be given. You should find at least one example of all of those on this video. Okay, that's it. See you next time for geometric, and bye-bye.